So last class we have discussed about the gauge factor, how we can do the how we can calculate the gauge factor. So what is the gauge factor? Definition: gauge factor is it is the ratio of change in resistance with respect to resistance to the strain. This is the definition of strain gauge, where delta R is a change in resistance and R is the original resistance. For metallic strain gauge factor typically around 2. For for semiconductor materials gauge factor around, for semiconductor material gauge factor GF around 150 to 200, 150 to 200, 200. Then the variation with temperature and compensation. So temperature changes can affect the strain gauge due to expansion construction. The strain gauge material is the expansion due to applied the tensile force, and construction due to applied the compressive force. When we apply the tensile, so material will expand. Because of expansion, the length changes of the material, then length will come to change in length delta L. So this is the original to the original. That's so in this way a strain create based on the strain. So gauge factor can be calculated. Then change in electrical resistance, because length changes. So resistance R equal to resistance R equal to rho L by A. What is the rho L by A? A is a area, rho is a density, L is a length. So in this way resistance can be changed. So that's why we need to compensation, temperature compensation, so that the reading of the strain gauge will not be affected due to temperature changes. Second, second compensation technique used for self compensation material with minimal expansion. Use temperature compensation strain gauge with Wheatstone bridge configuration. So this is the wheat. This is the one resistance. We just like this. This one resistance. Another resistance. Output we are taking here. This is the resistance R1, R2, R3, and this is the strain gauge resistance. This is the strain gauge resistance. So this resistance can be changed another strain gauge resistance for compensations. In this way, we can do the compensation using the Wheatstone bridge. Next is environmental coating to shield temperature from the temperature fluctuations. And next is the adhesive. What is the adhesive? That's used in strain gauge. Adhesives are used to bond the strain gauge to the specimen. First, suppose that this is the backing material like this. In strain gauges, put it in this way. Strain material like put in this way. Here, hard material is this. This is the connection here. This is the electrical output here. Strain gauge. This is the backman. Adhesive is a technique that is used to put these strain gauge in the specimen. A requirement for adhesive: high shear stress. When a force or pressure is applied, it must be it must be higher, more and more stress. Second, durability under the varying temperature conditions. Durability under the varying, the common adhesive epoxy, canon, surglet, and polyester resin. These are the material. दूसरा durability under the varying temperature. It must be very durable when temperature changes. It resistance and strength should not be changed when temperature changes. Adhesive. That's needs adhesive. Adhesive used to bond the strain gauge to test the specimen. Name of the common adhesive like epoxy and polyester resin. And next topic in our strain gauge is roster. What is the roster? The roster are arrangement of multiple strain gauge in a specific pattern. So, different specific pattern में arrangement of strain gauge that measure the multi-dimensional strain is called a roster. So type of the first is rectangular roster. The separate gauges by 45 placing a strain gauge on both x and y coordinate. This is the x coordinate rectangular. This is the x coordinate here, y coordinate here. Third, another we can put at the 45 angle. So this is the E1. Suppose that this is the strain E1 is in x direction, E3 is given to y direction. So we can calculate the EXY, the resultant of this E2 minus this is the E2 in E2 is the between the 45 angle from each x and y direction. So EY is nothing but E2 minus this is the E2 minus E1 plus E3 average of E1 plus E3 EXY in this direction we can calculate. This is a rectangular. Due to the placement of strain gauge, the mass for rectangular gauge is more simple than delta gauges. Delta gauges have wider coverage versus rectangular gauges. The strain gauge are separated by 60. The middle strain gauge aligns with the XY. 30, 90, 60. This is the this representation the delta roster strain gauge. One with 45 degree from the third. Each are the from 60 and 30 degree from the x-axis. Rectangular roster three gauges are 90 interval. Delta three gauges are 60 interval with each other. So used to calculate the principal strain gauge in direction complex bonding. Next, we will discuss the capacitive sensor. So what we have studied in this rectangular gauges, like due to placement of gauges, mechanical strengths like this, and roster arrangement. This second is a capacitive sensor. Capacitive sensor is a devices that detect the change in capacitance to measure the or detect the physical quantity as displacement, pressure, humidity. So three quantity we can measure. First displacement, second is a pressure, third is humidity using the capacitance sensors. The formula of capacitance we know where we will C equal to this is C equal to epsilon A by A. This E is a permeability, A is the area, overlapping area, A over D is the distance between the plate. This D is the working principle of this. The capacitive sensor work by detecting the variation in capacitance caused by change in geometry or material properties of system. In variable distance parallel plate type, change in the separation D between the plates. Suppose that this is the capacitive plate. General, this is the capacitive plates. This plate is a fixed, one is a fixed plate, another is a variable plate. In this when force or displacement apply on this, so this is a parallel plate capacitance. The distance between this both must be D. This is the distance between is D. Overlapping area between the both plate is A. So this is the parallel plate arrangement. The variable distance capacitance. This is the dielectric material put it in blue color. This is the green one, the conductive plates area A, and this is the green colors one, like in this way. The composed two parallel plate capacitive separated by dielectric material, air or another insulating medium. One plate is fixed while other is movable, enabling the variation in plate separation. Operation: when an external force or displacement move one plate one plate of the distance d changes alternating capacitance change. Means this is the C equal to epsilon A upon d. D is a distance between the plate. Epsilon is a permittive of medium. A is the area between the overlapping area. When external force or displacement move one plate and the distance d changes alternately. So change in capacitance is measured and correlated to the physical parameter causing the plate movement. Key feature: linear relationship. Small change in d lead to proportional change in a capacitance. High sensitivity, effective for measuring a small displacement. Non-contact measurement oppose the without direction, reducing the wear and tears. Linear, three types linear relations. Small change in d lead. This is, suppose that this we can draw capacitance C and displacement D. So small change, this must be linear. Up to small change, this must be linear in capacitance. And high sensitivity. What is the sensitivity? Means change in output by change in input. Means a small change in inputs, it produces a large change in output. That's why its sensitivity is very high. Sensitivity change in output by a change in input. Change in input means very small change in inputs, it creates the high change in output. That's why its sensitivity is very high. Non-contact measurement without direct control, reducing the TRM. Next is a application for displacement measurement used in micro mechanical systems. Those are, for example, detecting in tiny movements like precision instrument measurement. Pressure sensor for diaphragm move due to pressures. Alternating plates are separated. Suppose that this is the capacitive. This is the application and pressure sensor. This is the capacitance. This is the air is diaphragm. Here is when pressure applied on here from here. So diaphragm deflect in this way and deflecting. That deflect, this is connected on this. So according to distance of this between the plates, it changed. Distance between the plate is changed. In this way we can measure the pressure in terms of change in capacitance. Next is we can use the proximity section, detecting approach of objects based on a change in dimension. Touch screen. Second is capacitive sensor, variable area type. Variable area type. Second, the area type capacitance sensor. The capacitance changes is effective overlapping area must be changed. Right now we are changing the distance from here. We can, this is P equal to epsilon A via A. This is the epsilon A via D. Above equations we are changing the distance. Right now we will change the capacitance overlapping area between them. So then capacitance will be changes on this principle. So suppose that this in the first moving plates. Suppose that this A is overlapping area. So we can, if move one plate in horizontal direction, so overlapping area here also is also rotate this fixed movement here, moving the plate one place, overlap area also changes. In this arrangement, so these three arrangement are shown when we are changing the capacitance overlapping area. According to this, the capacitance of this capacitance sensor changes. This is also again one diagram where we are moving this plate horizontally We can move in this directions, we can move in this direction. So here overlapping area can be changed, here a is changed. So in this way we can do like this. Permeability of medium and low edge overlapping plates, d the distance between the constant. Three type of variable area capacitance sensor: parallel plate type, second is a separated separated plate type, third is cylindrical type. So parallel plate type, we can see this is the parallel plate type. This one is there, another plate move like this. These are plate, we are moving the plate 1 and 2, so overlapping area can be changed in this way. So this is the parallel plate like this. A teeth plated we have seen just above this. This is the type of teeth places. This is the type of teeth placed where area is changing according to capacitance change. And another is cylindrical type. We can also discuss this is the one in this way. Two cylindrical are there in this way, and one cylinder within inside this, and another cylinder within outside this. So we can change the using this type of arrangement is called cylindrical type arrangement. Structure: so two flat parallel plates with one plate movable in the plane of the others. The overlapping area A between the plates changes as the movable plates are slides. The capacitance can be increased or decreased according to depend on the overlapping area. Means the capacitance C equal to epsilon A via D. If we are increasing the area, so then capacitance can be increased. If we are decreasing the area but capacitance, but this can be done up to particular limit. After that, it can show the non-linear behavior. So movement is linear proportional to change in capacitance. When we are changing the area, then capacitance is changing. Two plate, two flat plate capacitance, one plate movable and another plate is non-movable. So capacitance increases or decreases depend on the overlapping area. Movement is linear and proportional to change in capacitance. Next is application used for linear measurement such as the actuator position or sensing. So this we can use in the overlapping areas. So two parallel plates, one is movable. Suppose that this is a fixed plate, and this is the movable plate, movable. In this way, we can measure. Application. Second is a teeth type serrated type capacitive sensors. Two plates are interlocking teeth or serrations. One plate is movable, affecting overlap area changing incrementally. This is the operation. So teeth providing stepwise changes in capacitance. The high precision due to fine control over using this application. Advantage: first, greater sensitivity and more resolution. Sensitivity, it provides the sensor because it's small change in input, it's produce the large change in output. That's why sensitivity is greater. The definition of sensitivity, it is the ratio of change in input, change in output to change in input. If we increase small input increment in these type capacitive sensors, it create a high output. That's why its sensitivity is very high. Resolution compared to plane resolution compared to the plane is very high. दूसरा, resolution and sensitivity compared to the, because resolution means minimum detectable change in detectable output, minimum detectable changes in inputs, so that instrument can be read that way. So both things, sensitivity and the resolution, are very high then compared to parallel plate capacitance. Compact design suitable for micro mechanical systems. Application: rotational positions sensing, Common in rotatory encoder for detecting angular position. Incremental measurement were ideal for system needing for fine-grained positions. Third, cylindrical type. That's the cylindrical type structure. Two axial cylinder surface. One is fixed, and another is movable or slidable. Effective overlapping area A changes in inner edge moves. Suppose this is the one cylinder out. That's the outer cylinder. Within this cylinder, this is the inner cylinder. We are moving from here. As inner cylinder move in inner and out, so capacitance is changing. So the capacitance vary as inner cylinder slides or rotates alternatively overlapping area. The uniform motion ensure consistent and repeatable changes in capacitance. Advantage: high sensitivity for rotational or linear movement. Durable design with minimum variable applications. Rotational sensors for angular displacement measurement in motors. Linear displacement in hydraulic system and industry machinery. So general feature about variable area sensor. Advantage: high sensitivity for detecting small changes in input. Durable with fewer moving parts. Can operate in harsh environment. Limitation: the sensitive or external to noise on environment. It required precise alignment and calibration. Design and consideration. So design and to ensure uniform dielectric medium to minimize the measurement error. Suppose that this is the parallel plate comes, the dielectric should be uniform so much to minimize the error. If it is not uniform, that it can be create an error. This is the dielectric medium. Dielectric DE medium.